All right. So last class we left off with factoring your greatest common factors and factoring by grouping. So this section we're looking at factoring trinomials. So don't forget that factoring is the undoing of multiplication. So in other words, if I had these two binomials and I would have FOILed them out, distribute the x, distribute the 5, you'll be left with this, x squared plus 2x plus 5x plus 10. Then combine your like terms in the middle, and then that'll give you that 7x. So you have x squared plus 7x plus 10. So factoring is taking this trinomial and breaking it back down to the two sets of binomials.
Is that the right section number?
You know what? I think it is not. Let me
I'm
check.
writing this down.
It's up to you. Yeah, that's notes though. Yeah, that's your notes. Let me see what your guys' section number is for this one. I forgot y'all had a different. I think it's like 13. Um, 13.2. All right, so that's 13.2. All right. So let me erase this so we can talk about what's going on here.
Two seconds, please. Don't start explaining yet. Let me just finish writing this down so I can focus. If
You
you
know
don't
what?
mind.
I'm gonna need you to. You all right?
Okay.
All right, just let me know when you're ready. It's all good.
Okay, I'm cool.
Oh, you literally meant 2 seconds. All
Yeah.
right. Anybody else need that top part before I scroll up? Make sure we're good. All right. So let me erase this. So there's going to be 4 scenarios that you guys will come across that from the jump, you will always be able to tell what your signs are supposed to be inside of these parentheses. All right. So if you lean on this, no matter what's going on, no matter what numbers you have here, you'll always be able to tell at least what signs are supposed to be in the parentheses. All right. So the first thing you do is look at this back sign. If it is positive, that means that your signs are supposed to be the same. And then this sign will tell you which one to use. So that means that both of your signs in the parentheses, I don't want to use red. Both of the signs in the parentheses are supposed to be positive. All right. Go to the back sign. If it's positive, that means they're supposed to be the same. This sign tells us which one to use. So that means both of our signs should be negative. All right. Questions on that?
Okay, so the answer is going to be positive or negative depending on the first one, if it's addition or subtraction, or positive or negative.
Well, you always you go to the back one first.
Okay.
Uh-huh. And now I'm just re-explaining it just for anybody, not just you, because you just said the last part. I just want to make sure everybody's good on the whole process. So you always go to the back one first. If it's positive, that means both of your signs in your parentheses will be the same. And then the first one tells you which one to use.
Okay.
Yeah. So that's why both of these are positive and then both of these are negative because of this front sign. All right. So before we get to the chart,
Okay, I'm sorry.
no, you good.
Start with the back side. If it's positive, you're supposed if it's positive,
Your
wait a minute.
signs are going to be the same.
Okay, if it's positive, both sides be the same. And then what'd you say about the first sign?
It tells you which one to use.
Okay. Thank you.
Mm-hmm. All right. Make sure we're clear on that. We'll talk about when the back sign is negative in a second, but we're just dealing with if the back sign is positive. Is everybody good? So once again, if the back sign is positive, it tells you that your signs are going to be the same, and then the front sign tell you which sign it's supposed to be. All right. So now, the first term in each, remember that was a product of this. X times x gave you x squared. So here, all we have is x squared, so that's what we'll do. X times x gave us that x squared right here. Now, you look at your factors of 6 and say what factors of 6, whether it be 1 times 6 or 2 times 3, will add together to give me 5. And of course, that's 2 and 3.
Now what?
Well, there's only 2 different ways you can get 6. 1 times 6 and 2. 1 times 6 and 2 times 3. Which one will add together to give you 5? That would be 2 and 3.
2 times 3. I mean 2 plus 3.
Mm-hmm.
Oh, okay. All right.
Because remember, your signs are the same. So positive 2 plus positive 3 will give you the positive 5.
Okay, I'm trying to write these notes as you got them so I can use it as a guide. So.
Mm-hmm.
So x would be, all right. So,
Mm-hmm. Same thought process goes on with that second one. We have x squared, so first term in each is going to be x times x. Now in this next one, the factors of 12 that will add together and give you 7.
4 and 3.
Yep, you got it.
Oh, I'm not on mute.
why do you got what's the what is that at the bottom? Oh, 3 times 4. I see it. Never mind.
All right.
It almost looked like a 5 to me. I'm like, what is that?
Yeah, that's because of that circle. Mm-hmm.
Yeah, I got you.
All right. Questions on the first 2? All right. So the next 2, notice this time my back sign is subtraction, so that means our sign should be different. So it doesn't matter whether you do plus or minus, minus or plus. There's nothing in the parentheses, so we'll put them in there accordingly. And then the front sign tells you which one should be, which number should be greater. So let's look at what that means. So we know we're going to do x times x once again.
That first word say on the plus
What is
sign?
that? Yes, in the red.
Greater.
Okay.
Oh.
Yeah. So looking at our factors of 6, now our signs are different, so they have to subtract from each other to give us 5. So that means this time we will use 1 times 6. And the 6 is going to take on the plus because that's the greater number.
6 is going to take off the plus. So that, okay. So if you actually subtract the 1, it'd be 5.
Mm-hmm.
Okay.
Yeah, because remember, we will FOIL this out. Remember this process right here, we'll FOIL it out. And then the numbers on the inside will end up subtracting from each other to give us that 5.
Mm-hmm. Okay.
And remember, you always can go back and check it. As a matter of fact, I got it right here. You can always go back and check these by multiplying it out yourself and see what happens. Remember, if it does not multiply back out to give you what you originally had, then it's not the correct factorization. So you always can check your factorizations. All right. And then the fourth one, same type of situation. We have x This is x squared, x times x, different signs, because our back sign is a minus. And when our factors of 12 that will subtract from each other to give us 2. Let's see, 4 times 2. Is that supposed to be 4? I have 6 times 4. I think that was supposed to be a 4 right there. I made a mistake and put 2. I might have erased it and put back 2 by mistake. So we're looking at 6 and 2. And notice the 6 is negative because of this sign right here. The 6 is the one that get a negative sign.
And that's because you said it was greater, right?
Mm-hmm.
Okay, I just want to make sure I'm following.
Yep. So the greater number is always supposed to get the
plus sign.
Wait, no, the negative. See, here is negative. Here it was plus.
So how would we know when it doesn't even matter? The higher number is going to get whatever sign you're working with.
Right.
Okay.
Exactly. All right. Questions before we do some more examples?
Don't move yet, please.
Mm-hmm.
Okay, I'm cool. Thank you.
Not a problem. All right, I didn't write any more examples on this page. Hold on, that was 6-5. Where all my examples go? All right, well, let me pull out the book. I must have them on another set of notes.
When you're doing these factorings, you're always going to have a bracket with a positive and a negative in it, right?
Well, it depends on if your sign is negative. Now, if it's positive, notice your signs positive, negative.
No, what I'm saying is within the brackets, like X plus or X negative, there's always going to be 2 sets of brackets.
Oh, there's always going to be 2 sets of parentheses, yes.
Okay.
Yeah. All right, so that's one I just did. All right, so let's look at this first one, x squared minus 12x plus 35. So, like your classmate mentioned, go ahead and set up your 2 sets of parentheses. That's always going to be the case. That's what you're trying to do. So I always suggest that when you go about doing these, always do what you know has to happen. So first thing you know has to happen is I have to set up my 2 sets of parentheses. Next, what has to happen is that my sign right here says that it's positive, so my signs in my parentheses have to be the same and this one tells me which one I'm using. So that means both of my signs should be negative. So those are things that has to happen.
I have a question. Say the negative part again, because in my mind, the first half was positive because it was the back sign.
All right, so now the back sign don't tell you what your signs are. It tells you that they're going to be the same.
Oh, okay, got it. And then you use the first sign
to tell you what it's supposed to be.
All right.
All right. So we only have x squared in the front, so it's x times x. And now we need the factors of 35 that will add together to give us 12. And that's 7 times 5. And that's your factorization.
Okay.
Any problems? All right, next one. Sign in the back is minus. That means my signs in my parentheses are supposed to be different. Remember, this front one would tell us that the greater is supposed to take on that sign. So r squared would just be r times r. Now I need the factors of 42 that,
Nothing, go ahead.
Okay, that will subtract from each other. Remember, our signs are different now. Remember, before our signs were the same, so they were going to add two together to give us the middle number. This time our signs are different, so they're going to subtract from each other to give us -1. And so it's going to be 7 times 6. And so that means my 7, though, would take on the negative sign because that's the greater number. And then the 6 would be positive.
The 7 would, okay, it's the greater number because it's the higher number. Okay.
All right, next one. Now, once again, start off with what you know has to happen and don't deviate from your rules. Our signs, because of this back sign, says that they're supposed to be the same. And this front sign tells us which ones to use. So it means both of our signs are going to be positive. Now, a squared going to give us a times a. All right. So now we look at 10 and say, what are my factors of 10 that will add together? Like I said, don't change what you do. Just examine what you have. What are my factors of 10 that will add together to give us 2? So we got 1 times 10 as an option. 2 times 5 is an option. Will either one of them add together to give us 2? The answer is nope. And that means it is prime. You know, we talked about that last class, that if something cannot be factored, then it is prime.
So which set of numbers would we use? The 1 and the 10 already that's broken down, or the 2 and the 5?
Well, you can't. That's why we write prime.
Oh, so there's actually no numbers that go in the parentheses?
Right. That will make, remember, your goal is to create this trinomial by distributing, do your binomial distribution. So you have to ask yourself what factors of 10 can add together to give you that 2 right there. And that's not going to happen. If you put a 1 and a 10 there, you have to give you 11 in the middle. 2 and 5 will give you 7 in the middle.
Right.
And so, yeah, there's nothing that will give you that trinomial. So it's prime. It's not factorable.
Okay.
Excuse me. All right. Do this one and a couple more. Let's make sure we see all types of scenarios. So once again, back sign is positive, means our signs are going to be the same. This one tells us to use the plus sign, so we got pluses in both cases. Now, we have x to the fourth right here and x squared right here. So that would just be x squared times x squared. X squared times x squared is x to the fourth, and then that will give me x squared in the middle when I add my terms.
So we're supposed to know that.
Yeah, you're supposed to take what we did here and apply it here. But that's why we're going over it, you know. But that's what they expect you to do, yeah. Because r times r gave you r squared, and then you had the r right here.
What's that word at the plus sign on the back?
Oh, it's the same one. I'm using the same words. This is same, and this is used. Yeah, the same words that I use up here and stuff. I'm just using the same. Just reminding you what was said. Yeah, this is same, this is used.
X.
So now you want your factors of 8 that will add together to give you 6.
4 and 2.
You got it?
Doesn't matter which way you put the factors.
Nope.
Okay.
Nope. All right. Questions before we do another one? Let's get minus.
This one here, will we use the y or the x? It's got x to the second, so will we use y and x in the parentheses, or just?
Nope, you got it. Got to use y and x in the parentheses.
Okay,
Yep.
so one would be y and one would be x.
You got it. Yep.
Okay.
So, signs need to be the same. I'm going to use that negative.
Okay.
Yep. First term each is going to be x, because x times x. And we need the factors of 6 that will add together, because our signs are the same. Add together to give us 7.
Add together to give, okay, yeah. I thought we was doing the 6.
Yeah, but yeah, factors of 6 that will add together to give you the 7, though. Right.
That would be 6 and 1, okay.
Mm-hmm. And so then, like you said, we want to include the y as a part of this back term, because we got y squared back there. So that'll be y and then 6y.
Mm-hmm. Okay.
And that's it. All right. Questions before we look at the next one. Make sure we're all right. Here, normally, if you notice all the ones that we've had up to this point had our variable first, our leading term first. So you can rearrange your terms. Just remember that whatever is positive needs to stay positive, whatever is negative needs to stay negative. So my t squared is still positive, 13t is still negative, and that 40 is still positive.
Oh, that's just you rewriting it over.
Yep.
Okay.
Yep. Putting it in an order that we normally would have.
All right.
But that's not good because both of them X, like this basically.
Okay.
Yeah, the other one had both of them had variables.
Does it matter what do we put it in? Like for the example before this one that we just did, if we put the 2 in front of the 4, would it matter?
Nope.
Like
Nope. You could have put 2 right here in the 4
okay.
right here.
Okay, I just want to make sure because I know would it count it wrong in math lab?
Nah, as long as you did x squared plus 2 and x squared plus 4, it'll still be the same thing.
Okay.
Yeah. Same thing here. If I wanted to put the 6 here and the 1 here, that still would have been all right. Now, when you go to here, you can't put the 7 here and the 6 here without including their signs. So the 7 has to be negative, 6 has to be positive. If you were to put them into different parentheses, they have to, whatever signs they are, has to stay those signs. Yep. All right, so here we have T and T. Both of our signs are supposed to be negative. And we need our factors of 40. And let me do that. Factors of 40 that will add together because we have the same sign. Add together to give us 13. That's 8 times 5.
Mm-hmm.
All right. Questions? Any questions? All right. So this next one, I remember that one of the last things that we talked about last class was you wanted to look.
Problem right here.
Huh?
That's it.
For this one?
Yeah.
Yep, that's it. Yep.
Why is it so short?
I don't know. That's just it.
That's a question I would ask.
It's the same thing. Maybe I didn't. I don't know. I thought it took the same amount of time. But with these other ones, I was introducing concepts. Here, hey, I'm thinking y'all flowing with me, so maybe that's why I went that way. All right. Yeah, but really, all of these are that short unless I'm sitting back, answering questions by Miss Christina. And I'll just playing.
That is hard. Don't do that to me. I gotta make sure I understand what is going on.
But yeah, no, you good. I'm just messing with you. Just doing it because I can. Just doing it because I can. But yeah, that's the only reason why the other ones were maybe shorter. If I was stopping saying, hey, this sign is this and this sign is that, and this one I didn't do it, I just assumed that you guys were flowing with me. So the next one, we have 3m squared minus 24m minus 60. And remember the last thing that we talked about last class was making sure that we look to factor out the GCF first, greatest common factor. Now that hadn't come up as far as any of these other problems, but it is here now. When I look at this term, this term, this term, I can pull a 3 out of all 3 of them. All right. So if I pull a 3 to the front, that'll leave me with m squared 3 times, 3. If I pull a 3 out of the 24, that leaves me with 8. And if I were to pull 3 out of that 20, out of the 60, excuse me, that would leave me with 20. And remember, if you have to check or you need to check, just multiply back out and see if you get what you originally had.
Oh, wait a minute. Okay.
Now, we're not finished here. I'm just saying that's the first move. You always want to look to see if you can factor out a GCF, greatest common factor. And don't forget that this 3 is always going to be a part of your factorization. So in your final answer, make sure the 3 is involved. Sometimes people will go through their factorization and then forget that they have a 3 there, then they get it marked wrong.
So,
All right. So our signs are going to be negative and positive. They're going to be different because we have that back sign back there, which is negative. First term in each is m. Now we need the factors of 20 that will subtract from each other to give us 8. And that would be 2 times 10. And the 2 is going to be positive, and the 10 should be negative. And that comes from right here. Remember, the greater is supposed to take on that sign. That's your factorization.
can you go over it again? I felt a little lost. Threw me for a loop with it. Like, okay, so
Mhm. So the
just
first thing we did is we took 3 out of each one of these terms originally.
uh
And so that's how that 3 got right here. 3 times m squared is 3m squared. 3 times 8 is 24. 3 times 20 is 60. So we didn't change the problem. We just pulled 3 out of each term.
okay.
So after that, we're just doing the same thing that we've done up to this point, which is we look at our back sign first. Back signs is negative, so it means our signs are supposed to be different. All right. And then this sign tells us that the greater will take on that sign.
Yeah, the negative.
Mm-hmm.
Okay.
So we know that the first term each has to be m because all we have is m squared.
Right.
Now we're looking at the 20. We say, what are our factors? What 2 numbers multiply together give us 20, but we'll subtract from each other to give us 8.
Okay, that's the 2 and the 10. Okay, so that's how you
Mm-hmm.
got the 2 and the 10. I got it. Thank
Mm-hmm.
you.
Not a problem.
All right.
And then the 10 got the negative, and the 2 got the positive. All right, questions. Make sure we're all right. So I take it that somebody want to do another one like that. I think I
Well,
heard
thank you.
somebody. I think I heard somebody say that.
Yeah, use a fraction this time because I'm pretty sure there's going to be fractions in it.
Well, if you see one with a fraction, you make sure you bring it to class so we do it.
Okay.
And yeah, so it's not a problem. Just bring it to class and we'll knock it out. But the examples that I see here, none of them have any fractions. So you might be all right. You might be all right.
Cool.
But like I said, if they do throw one in there, try to throw your curveball, make sure you bring it to class. And then we'll make sure we cover it. I won't hit y'all in the face with it if I don't see it. All right. So we have 2x to the fourth minus 26x cubed plus 84x squared. All right. Hold on. Let's see one.
I have a question. Say if we're doing our factorization and the factors we come up with can be like broken down to a smaller factor.
If it can be, then you're expected to keep on going till you factor completely.
Okay.
Yep. So the directions will probably say factor completely. Let me see. Yep. That's what it'll tell you to factor completely. Because technically if you were to factor out a GCF, then that's factoring. But if they don't, they don't say factor completely, then they really can't hold you to this right here. You know what I mean? So the directions will say factor completely. Mm-hmm. So once again, we have a trinomial, and the first move that we have is going to be to factor out the GCF. Now keep in mind, they're not going to tell you to do this. but they're going to expect you to do it. So you always want to look for the greatest common factor out of all your terms, if it exists. If it exists. So it's going to be, if you look at it, all of our numbers are even. So if nothing else, you know, you can pull a 2 to the front. And each one of these have at least 2 x's involved. So we can pull out x squared.
16.
Say it again.
Oh,
Oh, that was
no,
me.
13.
13. Oh, you're talking about in the back? Okay, let's get there. So here's going to be left with x squared. And then you said that's 13x. And then the next one's going to be
42.
You got it, sir. All right, so before we go any further, anybody have any questions? Make sure we good. So was that you singing, Miss Christina? Was that?
I'm good. I'm cool. I ain't got nothing to say.
Okay.
All
right, cool.
I just had to think about it. That's all.
Uh-huh.
I'm cool.
Right. All right. So signs are going to be, because this is plus, signs are going to be the same. And this one tells us which ones we need to put in there. Both the signs are going to be negative.
That'll be it.
Both of them be x. Now we need our factors of 42 that will add together because we have same signs. They're going to add together to give us 13. That'll be 7 and 6.
I gotta get the add together. All my mind automatically goes to multiplying. That's why I'm like, I gotta think about it for a minute.
Yeah, because see, they multiply together to give you 42, but they add together to give you the 13. And once again, you always can go back and do your FOIL to check to make sure that your trinomial will be produced. So don't forget that. All right, so somebody said they want to put a number in front of that x. I hear you talking. Okay. So let's look at 13.3.
I think you're the only person that hears that.
Hold on, let me see. I should have this somewhere. Where are all my factoring notes? Perfect square trinomial. Let's see what's going on here. Sum of squares. Factoring trinomials when. Oh, okay, so these are all the notes right here. They just, well, that's not that much. Okay, anyway. I don't like these notes. Let me go back to where I was. All right. All right, so let's look at 13.3. Flatten trinomials in the form of ax squared plus bx plus c. In other words, what it's saying is that a is not equal to 1 now. So before, up to this point, what was sitting in front of x squared was equal to 1. So now we're about to put a number in front of that and factor this stuff out. All right, so the method that I pretty much go through as far as showing people how to do it is factoring. It's called factoring by trial and error. Just because when you're not that efficient in factoring, the more you practice factoring by trial and error, the more you get used to factoring, the more you get used to the process. Now, there are other methods out there, like slip and slide method. I think they got an AC method. I wanted to have that in one of these sections. Got the AC method and so on, but factoring by trial and error helps you see the inner workings of factoring, and really beneficial to people. So that's why I always lean on that. But if you want to learn the other methods and depend on the other methods, that's fine. Because a lot of the other methods, once you get used to them, you're not really thinking. All you're doing is just doing some numbers, and next thing you know, you got to think. And I want you guys to be thinking about it. So, but feel free to look up other methods. That's cool. I will not, mark it wrong because I don't see the method that I chose to show you.
I hope your method is the easiest one.
It's going to help you learn how to factor. I'll say it like that.
All right.
So the first thing you have to do is start off with what we know has to happen. First of all, you're going to have your two sets of parentheses, and our signs are going to be the same, and both of them are going to be plus. That's what we learned in the last section. That's what has to happen here. Now we're looking at our factors of 2. It's just 1 times 2. And then our factors are 6. 1 times 6 and 2 times 3. So make sure we're all right. These are our choices here for our factors. Matter of fact, I'm gonna color that, make that green. All right. So we don't have a choice for 2x and x, 2x and 1x. All right. So now when we look at 1 times 6 and 2 times 3, remember that we want to get 13 in the middle. All right. So let's say if I decided to use 3 and 2. Now you have to ask yourself, are you going to get 13 in the middle? I already know that 2x times x will give me 2x squared. I already know that 3 times 2 will give me 6. That's why I chose these numbers. But what I have to check is what I call a smiley face, is to get that middle number. So 2x times 2 is 4x. 3x times x is 3x. So that gives me 7x. So I know that this is not correct because I need to get 13x.
I don't understand that. Can you do it again?
Now, don't forget what we're doing is just foiling it out. Now, if you just have to foil the whole thing out.
I don't think it's that part. I think it's the 13.
Well, we haven't got to 13 yet.
Oh.
Yeah,
we saying the 13. I think that's the number you was working with. So you're just doing the 2 and the 6 right now still.
Well, I'm just showing you that it's possible to not get the 13x. So if you don't get your 13x, that means you need to try another combination.
Okay.
So we got 2x, we know the 2x and the x will work. We know this is plus and plus. So you say which combination will work? Well, now what we can try is a 6 and a 1.
Oh, and then it would add the 13.
Right. So it's all about finding the correct combination. The more you do this, the less it is about trial and error. And the more you start to see, okay, well, when I multiply 2 times 6, I'm going to get 12. You know what I mean? Like, that's what I'm talking about. Like, this process helps you to learn how to factor versus just doing stuff. And that's what's going to be more beneficial to you moving forward, especially going to the next class, because this class is not your terminal math class. So you do need to know the inner workings of factoring.
Okay.
So when you multiply this, 2 times 6 will give you that 12. 1 times x is 1x, and we get 13x, and that's what we needed. So this would be our answer.
So that purple, that 7, that 4 plus 7, we don't need to really worry about that because that's just showing us that that's not equal. So
right.
That's not going to be part of our answer is basically what I'm saying.
Right. But it's a part of your process, because if you choose the wrong factors, then you may come up with this, but you need to know that, hey, that's wrong. Now I need to choose some other factors. So I'm just taking you through the process. Like, I already saw that it was 1 and 6. I'm just showing you what could have been done if you would have chose the wrong factors. And how do you check? You know what I mean? Because that's what it's going to basically boil down to. You can throw any numbers in there, but when you fall it back out, what are you getting? Are you going to get this trinomial right here? And so that's how you check.
All right.
For that first part with the 2, like what did you do with it?
When you said the first part with the 2, are you talking about right here?
Yeah.
Well, 2x times x gives you x squared, 2x squared. So if you were to fold this out, let me go right here. If I were to fold this all the way out, that's 2x squared. That's 12x. That's 1x. And that's 6. Add these together, 2x squared. And that gives me what I originally had right here. So all I was doing was saying that you don't necessarily have to do all of that because you chose 2 and x and you chose 1 and 6 because you knew they would give you those numbers, but you want to check that middle. But if it makes it better, if it's easier for you to just check the whole thing, just fold it all out and just fold it all out and see if you get that trinomial, your original trinomial. So let's do another one. Everybody good with this one before we do another one? Roll up. All right. Now, if this is your first time seeing this in a long time or first time seeing it, period, don't be too hard on yourself. You always want to give yourself a chance.
These purple notes that you have up here, is that just another? Should we write that down?
Right there?
Yeah.
That's just me checking it. The answer was right here.
Okay.
And your classmate had asked about the 2x and x. So I was telling them where that comes into play, and I was just doing the whole check.
I just want to make sure I don't confuse myself. So I don't need.
Yeah, it's just me foiling it out. So we have 5x squared plus 7x plus 2. This one's kind of similar to the first one, though. That's all right. We'll save for the next one. So your parentheses, both of our signs are supposed to be plus. Looking at factors of 5, 1 times 5. Factors of 2 is just 1 times 2. So we only have one choice in each case this time. So it's all about putting them in the right order.
So then it would be, you would do the x, you would put your x's in their parentheses, right?
What are you talking about? 5x and x?
Yeah.
Yep. And now you have the choice of doing 1 and 2 or 2 and 1. But remember, our goal is to get 7x in the middle. And you always want to remember the foiling process. So you got to go this times this, which will give me my 5x squared. That times that, this times this, and this times this. So if I were to put a 2 right here, if I put a 2 right here, I'm automatically getting 10x.
Yeah.
So that's not going to work.
It's in the reverse.
You got it, sir. You got it. So I'll put the 2 right here and the 1 right here. And once again, if you want to check it, 5x times x is 5x squared. 5 times 1 is 5x. Next would be 2x. And then 2 times 1 in the back. So you see when you add those two together, you get your 7x in the middle. All right. Questions before we look at the next one? So once again, you just got to take your time and walk yourself through the process. Don't be in a rush. And like I said, you always start off with what you know has to happen. Then you go to the other parts. All right, we know our parentheses have to be there. And this time, because this back sign is negative, our signs have to be different. And our terms have to subtract from each other to get 13. All right, so here, 1 times 2 is the only way I can get 2.
1 times 7 is the only way I can get 7.
Okay.
So start off with 2x and x. Now, right now, we have plus and minus. Don't forget, we can move signs, so it's not that big a deal right now. What we want to do right now is put something in place that we can check. So we just putting 2x plus x minus. And once again, we can either do 1 and 7 or 7 and 1. That's my only choices, but one will work and the other one will not. So
So it
remember
would be, the 7 would come first because it would be 2 times 7 and subtract the 1.
all right. So you say you want to put the 7 here, or you say you
Yeah.
want. Now don't forget, if you're going to do 2 times 7, that means the 2 has to. You see what I mean? The 7 is
Oh,
going
so
to go.
that would count as an extra 1. What am I saying that right?
Well, you want the 7 to be here.
Oh,
You had the right thought process, but you got to remember the 7 has to be over here, for the 2 to multiply to it.
oh, okay.
You
All
see what I
right.
mean? But you got the
Yeah.
right thought process, and that's absolutely correct. So you just got to make sure you put them in the right spot.
Okay.
Mm-hmm. But that's why that's what I meant by when you do it this way. It makes you think about what you're doing, and it makes you bring in that logic that's necessary. You know what I mean? So you know that 2 times 7 is going to give you 14.
Right.
But let's follow it out. Let's follow it out. 2 times x is 2x squared. Well, 2x times x is 2x squared.
Mm-hmm.
And I get negative 14x. 1 times x is plus x. And then that's negative 7. So notice what we get here is 2x squared minus 13x minus 7. But notice we had plus 13. So whenever that's the situation, all you have to do is just switch your signs. All right. Once again, we had to switch our signs because what we had gave us negative 13, but we wanted positive 13.
Okay, I see that. All right. So if we were to answer that question and not make it a negative, they would mark it wrong.
Mm-hmm. Mm-hmm. You talking about if you don't switch your signs after you figure it
Yeah.
out? Yep. Mm-hmm.
Uh-huh.
Yep. Because there's only one factorization for this trinomial. This is considered a whole different trinomial because the 13 is negative instead of positive. Yeah.
Okay, got it.
Mm-hmm. All right. Somebody said they want to do another one. I got you. I hear you. All right. All right. 8x squared minus 22x plus 5. All right. So your parentheses. Our signs are going to be the same. Got a plus sign in the back, but both of them should be negative. All right. Now here we have factors of 5, just 1 times 5. Factors of 8, though, 1 times 8, 2 times 4. So we have choices here.
Okay.
I always say, always start with what you know has to happen. I have no choice here with this 1 times 5, so that's what I would start with. And I would just put 1 and 5 in there because I don't have a choice, right? And then looking at 8, now signs are the same, so they're going to add together. I need to get 22 in the middle. I can't put 8 right here because 8 times 5 will automatically give me 40. It's not going to work. But I know the number that gets me closest to 22 is
4.
Yeah, you got it. And so if I put a 2 right here, because now if I use the 4, that means I got to use a 2. I can't use 4 and 1 and 4 and 8. I got to use 4 times 2, which will give me my 8. And
Okay.
so, yep. So just reemphasizing that. that these combinations go together and these go together. So if you use the 8, you got to use a 1. If I use a 4, I got to use a 2. So just throwing that out there. And then FOIL it out to see if we get the right answer. So that's 8x squared minus 20x minus 2x plus 5. Excuse me. And we see we get 22 in the middle. All right. Any questions? Any questions?
Can we also have done it as 8x minus 1 and then the other one just the x variable?
All right, so let's look at what you're proposing. So you want to say 8x minus 1, x minus 5?
Yeah.
Okay, so let's check it out. So the way we can always do is just multiply it back out and see if we get what we originally had. So here, that'll be 8x squared. That'll be 40x. That'll be 1x. And that'll be plus 5. So you see here, we'll actually get negative 41 in the middle. And so what we needed, though, was that 22. Yeah. So this is why it's important. I'm glad you asked this question. This is why it's important that we actually go back and check, because you will always get the 8x squared and the 5 if you use, the right factorizations. It's just that the middle will be different according to the combination that you use. Yeah. Good question. Anything else before we do another one? I want to make sure you guys are good before we close out today. We're almost finished though. All right, so the last type of problem that they have in here, they call them perfect square trinomials because there's a formula that you can use to factor them. I don't normally emphasize the formula because you don't need it. Called perfect square trinomials because this is a perfect square and this is a perfect square. Now there are some factorizations that will need formulas, and we'll talk about those next class. So I try not to give you things that you don't necessarily have to do or commit to memory.
So what is this called? Perfect square what?
Perfect square trinomials.
Okay.
All right. So really all you have to do though is just do, if you know you have perfect square trinomials, if you do x here, because it's a perfect square, and then the perfect square of 36 is 6. Yep, you got it.
6.
Uh-huh. And you just write plus 6.
That's 6.
Yeah. So that's it. That's why I said that the formula is not necessarily needed. If you recognize your perfect square trinomials, 6 times 6 is going to give me 36. 6 plus 6 will give me the 12 in the middle. And that's that.
Oh, let me write this down anyway.
I'm not telling you not to write it down, most definitely. And you could write it as x plus 6 squared.
X times 6 squared, because that would equal 36, right?
Well, this x plus,
go ahead.
Yeah, this x plus 6 squared just makes you expand it back out and then you FOIL it. And then that will give you back that trinomial.
The x squared from the beginning.
Uh-huh. All right, let's do another one. Nah. I won't do that. That's not a perfect square trinomial. All right.
So here we have 4m to the fourth minus 4m squared plus 1. So you do want to check to see if it's a perfect square trinomial, just like we did here. First thing we did, I recognized that was x times x, and then at 36, it was 6 times 6. So here, is this a perfect square? Yes, this is 2m squared. And then yes, this is 1 squared. So that's 2m squared squared, and that's 1 squared. So what I would do is put them in. Now, my signs should be the same, and this one lets me know they should both be negative. So I'm gonna do 2m squared minus 1, 2m squared minus 1, and I always go back and check it. You know, just like I did here, I just didn't write it out. I said 6 times 6 gave me 36. 6 plus 6 gave me 12. So here, if I fold this out, I need to get this. If I don't get it, then it's not correct, right? So 2m squared times 2m squared is 4m to the fourth. 2m squared times negative 1 is negative 2m squared. Oh, negative 1 times 2m squared, negative 2m squared. Negative 1 times negative 1 is plus 1. Add these in the middle, and you get your negative 4m squared. So this is the correct factorization. All right. That's 10:42. I guess we good for today. So try the stuff out. See if you get stuck on anything. Just bring it to class and we can knock it out. You know, it's just a factorization. Or as always, if you want to shoot me an email or if you want to set up a Zoom session. Oh, there was somebody I was supposed to get back with. Y'all just made me think of something. All right. You want to set up a Zoom session, then let me know and then we'll go from there.
Mr. Tucker, I have a question.
Yes, sir.
It's concerning the homework on MATLAB. So
Okay.
there's instances when I work the problem out and I come up with a correct answer, but when I put it in, it's prompting me that I'm wrong. So I go ahead and rework it, and I arrive at the same answer again. I input it 3 times. Then after the final input, the answer that I came to, it's showing me that it's the correct answer, but I don't know. So what do I do when stuff like that happen?
Shoot me an email with that with the assignment and the assignment number that you want me to take a look at, and I'll go look at it and see what's going on.
Okay.
Yep. So, you know, just for example, just not for you, just letting everybody know. So let's say if it was even if it was on a test, you know, test 1, problem 5, I'm not understanding why I'm getting marked wrong. Can you check that out for me? And I'll go in and respond to your email.
Okay.
All right. Yep. Anything else? Anybody else before we close? All right. So you guys have a good one. Be safe. Have a great weekend, and I'll see you on Tuesday. Tomorrow, because it's Thursday, right? Tomorrow. Was anybody trying to take a test tomorrow? Anybody? Okay. So always, yeah. So I'm gonna try to make room for you guys to take a test. Only time I really have is on a Friday morning. So if you know you're gonna want to do it leading up to that Friday, shoot me an email so I can make provisions for that. Was somebody else about to say something? Somebody else? Okay. Everybody good? Everybody good?
All
Okay.
right.
I actually have something I need to talk to you about. It was regarding my last test grade.
Hold on. Ms. Young, is that you? You talking a little low?
Oh yeah. So it was regarding my last test grade. I did pretty bad. I was wondering if there's like any like type of extra credit work or anything that I'd be able to make that up because it was the first chapter. I remember when I did the review study, I did okay on it.
Mm-hmm.
But I kind of failed the test. I think it was just a lot of things I forgot.
Yeah. Oh, you can just take it over. That's how it works. You just take it over.
Okay.
Yeah. Just let me know when you're ready, or Like I said, if Fridays don't work for you, or we can't make something happen on Friday, then let Mr. Davis know when you're ready to take it over. You just take it over.
All right, thank you.
All right, no problem. All right, you guys have a good one.
See you later.
All right, take care.
All right.